new Malaysia student. Nice to meet you. I'm Yuri Shirataki, undergraduate student. Today I'd like to talk to you about my experiment result and future plan. Outline. First, I'll explain MAS easily again, and background of this experiment, material, device, method, result, discussion, and future plan. First, what's MAS? MAS means mycosprin-like amino acids. MAS have each UV absorbance maxima from 300 to 360 nanometers, and it's reported that some fish have MAS in length. So MAS protects fish eyes from dangerous UV effects. And my research team is to measure fish freshness from MAS decomposition in eyes. My first purpose is to see MAS spectrum. This. And next, background of this experiment. We couldn't see MAS peaks at some experiments we conducted. Before this experiment, we measured crude material, and other researchers used methanol to extract MAS. So at this experiment, I used methanol to extract MAS. And this fish is reported to have MAS, so I used this fish, this experiment. And I have two purposes of this experiment. One of them is to check and practice the extract process using methanol, and the other of them is to confirm if we can see MAS peaks from this fish lens. These are material and device. This fish is this in our garage, and spectroscopy, centrifuge, and cold cell, refrigerator, and freezer. Method: dissect 5 days fishes to lens. Storage the lens at minus 75 Celsius degrees for 2 days. Sow them at room temperature, about 21 degrees. Leave lens in methanol overnight, and centrifuge at 6,000 RPM for 15 minutes. Pick up supernatant by pipette and measure spectrum of them. Reference is only methanol. This is my result. MAS have absorbance peaks at the range from 300 to 360, so zoom up this range like this. Look at these two parts. This part have very, very loose arch, and this part fall down. Using Savitsky-Gore, I differentiated this graph secondary. For your information, Savitsky-Gore is one of statistics ways for both differentiating and smoothing data. Second, the derivative makes us see the original peaks as a minimum value. For example, this maximum value and maximum value. this is original data. This peak means this very, very loose arch, and this peak and this peak is this part. So then discussion. First, what's the peak of 339 nanometers? This. And second question is, can we identify 331 nanometers as a peak? This. First, what's the peak of 330 nanometers? This is maybe the device error caused by light source change. I set light source change at 340, and this part is also 340, so maybe the device error. This error exists when there are some things at sample and reference folders, and this error is very often about 0.001, so we should increase the peak of the sample so much that we can ignore this device error. Then, so we should change the concentration or optical path length in order to increase the peak of the sample. And next, can we identify 330 as a peak? This part is very similar to baseline. This is baseline, very similar arch. So we should change the concentration or optical path length in order to increase the peaks of the sample and confirm whether this part contains MS peaks. My future plan, first improve and find how to extract MS better. For example, this experiment I used only freeze, but I'll try to freeze drying and methanol amount change, sample state or concentration, and so on. Second, my future plan is continue to research how to get pure MS. We don't know how the pure MS the peak is, so we should pure MS, and we cannot identify MS without HPLC. If we use the HPLC, we need pure MS, so this is a very important task. But pure MS is now very difficult to get, so very hard task maybe. My third plan is spare more time to research the visible change of eye than now, and first photograph a moving image. Thank you for your listening.